V as a function of x. We are making an assumption of positive shear and positive bending moment. So next, we are going to perform static analysis. So positive is going up, summation about forces in the y direction is equal to 0. So you will have P/2 minus V as a function of x is equal to 0. So V as a function of x is equal to P/2. This is our equation 1a. Okay, I just decided to call it 1a. Okay. Then the next one is we're going to do summation about moment. In the z-axis, anywhere at point x is equal to 0, right? So what we have is minus px/2 plus by m as a function of x is equal to 0. M as a function of x is equal to px/2. Equation 2a. Okay. So now what I want you to see is if we were to, so this over here is for our cantilever beam. Okay. So if we were, so equation 1a and equation 1, I think you can see from here, right? Equation 1a and equation 1 are the same. Equation 2 and equation 2a are the same. So that is why, right, up to 0 to L/2 in this region over here, right, the loading condition is exactly the same if and only if at point A you have P/2 and AY over here you have P/2. They are the same. Okay, so I've proven to you, right, Y is the same, and why failure will occur at point C on the simply supported beam, and why failure will occur at point C on the cantilever beam. So the next thing we're going to draw now, we're going to do now is we are going to sketch. Okay, we're going to sketch the shear force and bending moment diagrams. Okay, and this is by observing the equations. Okay, by observing equation 1 and by observing equation number 2. Okay, so now I'm going to, so we know that this is a cantilever beam. Oh, sorry, this is simply supported. So I'm going to draw a simply supported. Right, so this is our beam that's simply supported. Okay, and then I'm going to draw our shear force diagram. Okay, so we have our load P applied down here. So this is our V. This is 0. This is our L/2. And this is our L. Okay, so we know from 0 to L/2, right, it's a constant. And this is P/2. And then at P or at point C, the thing will come right down. Okay, and it will come up to minus P/2. Why is that? Why is that? Because this distance to here is P, right? The P is coming down, it's going down that way. And then this is our, I'm trying to find my my mouse. It got missing again. Okay, So this is our shear force diagram. Then it goes up to P02 again. Then I'm going to sketch our bending moment diagram. I know I'm squeezing, okay? All right, so this is M, and then this is our distance X. And by looking at our equation, by looking at our equation number 2, right? So this is X, this is L over 2, right? This is L. It is a linear equation. Okay, so our bending moment will go up to here, and then from here it will come down. Okay, and at its maximum over here, right, is going to be PL over 4. Okay, and this is our Nmax. Okay, now if we were to just focus on our cantilever beam, right? So if on the other side, I'll just draw our cantilever beam. Right, so this is our cantilever beam. On the other side, mathematically, it's the same. It's only half the length, right? It's half the length over here. And we have our P over 2. So all I need to do is to copy and paste the whole diagram. Okay, and I just need to shift things a bit. I think I will do it over here. Okay, I will shift my diagram. This diagram, I will move it over here. Okay, it's fine. Okay, so we know that this is coming down. So all I need to do now is just delete. Okay, just delete here. That's all I need to do. Right, so you come down here. Okay, and then not come down, you stay down there. And then the other side, I just need to delete the other end. That's it, mathematically. Okay, so failure will occur at point C because bending moment is maximum. Failure will occur at point C because bending moment is at its maximum. Okay, now I like to look at. Since I'm doing this myself, I describe the trend or the relationship with the shear force and bending moment diagram with you. Okay, and this will be useful when you do your homework. Okay, what I want you to observe is this. Okay, so the first thing I want you to see is when shear force intersects 0, like over here, right? There is a possibility that bending moment is at its maximum. I will highlight over here, there is a possibility. Why I use the term possibility? Because you have to check. You don't take it for granted. Okay, you have to check that. You have to check. Okay, because later on, where we do compound loading, and where the shear force intersect the 0 shear force line at a few intersection, you have to check. Okay. Now another relationship you have to observe is this. Okay. When the shear force magnitude is positive, right? Like for this case, the magnitude is what? Positive. Okay. The gradient in the bending, squeezing too much. I do apologize. Okay, no, I will shift this side. Come on, Eugene. Come on, come on. Okay. When the shear force magnitude is positive, the gradient in the bending moment is what? Also positive. Okay. So what I want to show you is this. Okay. So we can see that this is positive. The bending moment is what? The gradient is positive. When it is negative, right? The bending moment gradient is negative. Okay. So where failure will occur for either both, okay, to be more specific, where failure will occur is usually where bending moment is at its maximum. So for a simply supported beam, it's at point C. In a cantilever beam, it's at point C also because the bending moment is at its maximum. Okay. Now, another thing I want to highlight regarding the bending moment diagram is, I know this is a lot coming to you, okay? It's just for you all to remember to recap what you have learned before. If this is 0, at the top is positive bending moment. At the negative is negative bending moment. Now, what does this actually mean? Okay, it means something. What does it mean? So if we were to look at the deformation pattern, okay, positive bending moment means the deformation is smiling face. Okay, that is where in this problem I'm so brave, but we have the mathematical proof already that I only focus on drawing the bending moment in the positive domain, because if you look at how the structure will deform, the structure will deform this way, right? And if we were to look on the cantilever beam, how the structure will deform, the structure will deform this way, smiling face. Okay. And when it's negative bending moment, or negative, you see over here, means the deformation is a sad face. Okay. And I want you all to like embrace what you see down here. Okay, I want you all to embrace what you see down, because the bending moment and shear force diagram can represent, can help us visualize deformation. Okay. Now what I'm going to do, I'm going to stop here. Okay. Now I've posted homework already. You can do the homework. Okay. Based on some of your knowledge, you have 2P. But if you have problem with the homework, don't worry. Okay. On Tuesday, I will continue again and hope you could remember. But if some of you want to do homework number 1, which I posted on Avenue to Learn, you could. If not, it's fine. Okay, don't panic. Okay, and I will stop my lecture here. Thank you for your time. Have a fantastic weekend. And those of you who have questions, please stay behind. I'll be here for another 10 minutes. Okay. Mark, Lou, are you there? Can you talk to me, Mark?
Yeah, I'm here.
Okay, you stay behind. Okay, we see anyone have questions. If no one have question, I'd like to have a chat with you.
Yeah, for sure, no worries.
The rest of you, any questions? Anyone?
So in the last lecture, you told us you'll show us how to like do like a summary sheet for the course.
Yeah, don't worry. I'll push that to Tuesday. Okay, because
Okay.
I have not enough content to write a summary sheet yet. Okay.
Right. Okay. Thank you.
Right. Any one of you have question except Mark staying behind? Anyone? How Paul, you okay? How Paul don't seem to be responding. Okay, Mark. I think you and me. Let me see. Do I stop recording? Let me stop recording first.